Good morning, friends. Welcome to Star Delta Conversation Techniques. So, we have discussed in previous classes simple circuits regarding to Ohm's law and Kirchhoff laws. Now, at the same time, we have covered transformation of delta connected resistance into star connected equivalent star connected resistances, vice versa. In this class, we are going to do some simple problems regarding to star delta conversation, where we require to solve the complex network into simple network to know the electrical characteristics. As we know that previous classes, once again we will recall it. What do you mean by a circuit? A circuit is a conducting path through which either an electric current flows or is intended to flow. An electrical circuit or electrical networks consist of active elements and passive elements. The passive elements are resistance, inductance and capacitances, and active elements are EMF sources, generators, batteries. And also we have seen active circuits and passive circuits. Active circuit is a closed electric path in which both active elements and passive elements are present, whereas in passive element is a closed electric path in which only passive elements are present. And also we have seen some terms regarding to the what do you mean the node or junction, what is the branch, what is the loop, what is the mesh, and we seen. For example, a junction is a point at which more than one ends of the elements are connected and division of current takes place. A mesh is the simplest possible loop or is a closed path in a network. Based on this network knowledge, we performed few simple problems with help of our basic formula Ohm's law. At constant temperature, the current in a closed loop is directly proportional to voltage. And based on Ohm's law, we performed simple problems. If the branches increases, then it is a tedious to solve with the help of series parallel circuits with the help of Ohm's law. Then we are going to apply our Kirchhoff laws, where the number of branches and number of sources increased. By using KCL and KVL, we have solved simple problems. What do you mean by Kirchhoff's first law? The algebraic sum of the currents meeting at an electric junction is 0. Sum of the current entering into a node equal to sum of the current leaving from that node. What is the second law? Or voltage law. In any closed path, the algebraic sum of product of current and resistance, that is a drop, in each conductor plus the algebraic sum of the EMFs is equal to zeros. That is equal to sum of EMFs plus drops equal to 0 in a closed loop. We have seen these all things. Based on this Kirchhoff laws, we have performed some somewhat complex problems also by writing number of loop equations. Branch currents by three techniques were used in KCLs. One is a branch techniques, loop techniques and nodal techniques, nodal analysis, loop analysis and branch current analysis. We performed the complex problems also where the network consists of more number of active networks and passive networks. And if the circuit is further complex in nature, then we cannot write the more number of equations to find its values. So, we require electrical characteristics for a particular element, particular load, a particular place. So, that response can be simplified with the help of star delta conversion method. So, we have already seen. So, sometimes it is difficult to solve the network problems having more number of branches with the help of our basic Kirchhoff laws and Ohm's laws due to a large number of simultaneous equations. These simplified by star delta transformations. So, what do you mean by the delta and star or star and delta? Delta connected resistances can be replaced by an equivalent star resistances. So, the resistance measured between any two terminals is or unchanged equivalent values. So, these are all we have seen in previous classes. Now, you can see here the complex, these are used calculated with the help of our Ohm's law, simple parallel series circuits. If the network is increased further, then we are used for using KCL and KVL circuits. If the circuit is further increased, then we have used our star delta methods. Okay. So, last class we have derived how to convert star connected resistance into delta equivalent and delta equivalent resistance converted in star. Now, we will solve some problems on numerical values, then you may get some idea. Now, what do you mean by, once again, what do you mean by star network? Here you can see, if all the similar ends of the resistors are connected to a common point is said to be star connection. If all the dissimilar ends of the resistance are connected to a common point in a closed loop is known as a delta connection. Okay. So, already you have seen these all things. So, what is this one? If the dissimilar ends of three resistors are connected together, then it is called a delta connection. And delta and star we have seen problems separately, and this is a star network, this is a delta network. Star consists of one common point that is known as a neutral. Delta, there is no common point. Here we are going to give the supply one phase and supply another phase, supply another phase, the which is the current is connected here. Similarly, here also we are going to connect here three phases. These are the terminals outside. Internal we are going to connect with the star or delta. Now, let us recall how the star connection and delta connection changing. So we know the directly formulas we derived in previous classes. Now here is the just remember that simple values, that is the R1 is regarding to star connection values, and R12 that means resistance connected between the 1 and 2 node, similar here. So regarding to the delta values, okay, single that means at node 1 this is equal to node 1 regarding to the star values, and R12 subscripts regarding to the delta. Now based on this one, so we derived how the star is connected to the delta. Okay, so how your work calculated once again. So here how to convert the star to delta. Now here once again you can see here this is star, here given the R1, R2, R3 is given. I want equivalent values into the delta. So that purpose I am going to convert in delta form. So here I want to connect, this is a delta connected this terminal. So this is a R12, R23, R31, where the terminals represented are represented by, this is a 1, this is a 2, this is a 3 terminals. Now I want these values, so I want this R12 value, this value is required, I want this one. If you know the R1, if you know the R2, if you know the R3, simply I want these values. So this value I want to know. So first of all write it line and write the sum of the product values R1 and R2, R1, R2 plus R2, R3, R2, R3 plus and R3 and R1, write it R3, R1, okay, divided by, and R12 and opposite branch, this is equal to, write it simply R3. So this is equal to the this equation. Okay, so whatever value you required, simply write it, thus product up to R1 R2 plus R2 plus R2 into R3 into R3 into R1 divided by. So this is only one technique you have to remember, opposite branch, or you have to write it. Last class we have seen how to remember these values also. Now similarly R23 is the same, numerator value is the same, denominator is should be only changes, instead of R3 here, what is the opposite value? This is R1, write it the only R1, you are going to get this R23 values. Okay, so if you required, so we will see in details also in this one. Okay, so here once again I am going to write it, please listen carefully. So here what required, so what is given, so here given star value is given, this is a star, so these values are given, and for example this is R1, this is a R2, this is a R3 values is given. Equivalent values I am going to convert it. So how we are going to convert these values? So now I am, so terminals from ear to ear I connected one resistance here, here I connected another resistance here, here I connected the another resistance here. So this value is connected 1, 2, 3. So I write the 1 and 2, R 2 and 3, and R simply write the 3 1. So here I am going to convert values. What are the values is given? So these values here R1, R2, R3 is given. I am going to convert these values into R12, R23, R31. These are connected in delta, these are connected in star. Okay, so these are the old values is given, these are the new values I am going to find it. Okay, so then what to do? Simply, so just you write it, the equations, what are the equations you know. So here simply write the equation. Okay, so I want the R12 is required, then R12 can I write it, R12 is equal simply the sum of this one, what the value, R1 R2, this R1 and R2, this R1 and R2 plus R2 R3, this and this plus R3 and R1, these values, whole divided by, I want this value. Okay, I want this value. So what is the opposite value? So simply you write it this opposite value. What is on R3? Then this value is R12, we are going to get it. Okay, now I want to write the R23. Then what you are going to draw? Simply just numerator is the same, only denominator will change. So use now R23, can write it R R23 is equal to numerator R1 R2 plus R2 R3 plus R3 R1 divided by, here is R3. Where is R3? This is the R23. Where is R23? R23 is this one. Okay, so R2 is this one. Now R23 is this value. So what is the opposite value? We are going to this one, opposite value. What is that one? So you simply write it by R1. This is a thing. Stress, please remember that. Here you can see it, 1 and 2 come, 3 is missed, write simply 3 here. Here 2 and 3 comes, here 1 is missed, you write it 1 simply. Just remember it. Okay, so 1 2 missed 3, just R3. Or 2 3, here 1 is missed, R1. Numerator is the same. Similarly, write it another R31. Numerator is same, R1 R2 plus R2 R3 plus R3 R1 divided by, what's the R31? You can see here. So R31 is you are going to calculate these values. Okay, you are going to calculate R31. This is the 31 you are going to. What is the opposite limb? This is the branch R2. Okay, now write it. Then you are going to get it. Similarly, what we have seen, 3 and 1 is came here. 1, 2 is missed. Simply write it R2. So these are the equivalent values. So that means here what you have seen, here all values now you can see these values. So whatever these values are given in delta, these values are given star. So now whatever these values is given, converted to these values. Simply we can write it in delta. Okay, so we converted this resistance R1, R2, R3, we converted into R, R1, 2, 3, R1, 2, R2, 3, R3, 1. So what are the values? Single values is R1, R2, R3 is equivalently converted to the delta values R1 to 1. What is the formula? This is the formula. So numerator is equal. So whatever the values is given star R1, R2 plus R2, R3 plus R2, R1 divided by what are the value R12 is required. So what is this value is given here R3. So R12 is the required, is the 3 is missed divided by R3. Now I want these values. Simply same thing R1 R2 plus R2 R3 plus R3 R1 divided by R2 opposite this value. So what is this value? This R1, you write it the R1, or you can remember R1 R2 you are going to write in. So one is missed by R1, you are going to same thing. This is one technique you have to remember. Similarly you write this also. So these are the conversion star network converted into delta network equivalent resistances. Okay. Similarly, if write the delta also, delta to star conversion. So in this case we are going to calculate. So now delta values is given. What are the delta values given? Now, so 1, 2, 3. Now we can converted 1, 2 or 2, 3 or 3, 1. So whatever the star is given, converted to this one. Now if it is possible, if I convert delta to star, will I get the same values? Yes, obviously we are going to get the same values. Let us see. So these values are converted where, so is given, what is the value? R1, R2, R3 is given, now converted into delta forms, that is R12, R23, R31. If I converted delta, this given value, got values, results, converted once again back to the star values. Shall I get the same values? Obviously you have to get it. So now let us see how to that one convert. Now here I am going to convert these values. Okay, this is the R1 I want to know, R2 I want to know, R3 I want to know. So what are the values is given? This value given, this value given, this value. These are old values. Now I want to this one R1, R2, R3 is a new values now in this case. Now I want to know the R1. How to write it? Simply the technique what we have seen previous classes. Just you write it the values. Now what is this value is going to simply write the small delta inside here. What is this one? R1. What is this one? R2. What is this one? R3. Okay. So new values are R1, R2, R3. So I want to know the R1, R2, R3 with help of R12, R23 or 31. Okay. Simple you can write it. What is the basic formula here? So here whatever this R1 is required, then I want this R1 is required. Can I write it? Simply adjacent of 2 here. So this value into this value. So you can write it R1 2 into R3 1. So that is this value divided by sum of these values given R12 plus R23 plus R31. Okay, R31. This is the formula. I got it R1. Just multiply R12 into R31 divided by total values. Here the numerator changes only, but denominator will same. Now write it the another equation. So now you write it the R2. So here you are going to write it R2. Now what is the R2? You are going to write it here. I am going to this value required. R2 value is equal to, what is R2? Here the R2 is the here. R2 is here. Then R2 is equal to this one and this one. Then write it the R. Write it. What is the value between R12 into R23 divided by denominator is the same. Sum of this value R12 plus R23 plus R31. Same value you are going to get. So this value and this value is the same, but here only changes the numerator values. Okay. Now write it the R3. R3 value is equal to, what is R3 here? So write it in bottom. Okay. Here write the R3 value. Write the R3. R. So this is the value we are going to know. R3 is equal to, what is the adjacent values? This here the adjacent values. R23 into R31 divided by total values. Same this values you write it. R12 plus R23 plus R31. These are the formulas you are going to learn. Okay. So already we have seen these formulas. So how to convert? So star value to delta values by writing the equations, and how to convert delta values to star values. So once again we got the same values. If you substitute the numeric values, we are going to get the same things. Okay. So these are the basics we have learned, derived in previous classes. Now in this class we are going to substitute in instead of R1, R2, R3 numerical values. At the same time R21, R12, R31, instead of that one we are going to substitute some numerical values. So we will see whether this star connected resistance is converted to the delta or delta converted value star, whether you are going to get the same or any differences. Okay. So let us do it now. So what this is a summarized what we have seen. So star to delta. So star values is given and simply you are converted into delta values. Okay. Star, whatever the star values is given, this old one we are going to convert the, these are the new values. What is the formula? That is equal to this values. So this is equal to, what is the value? This is equal to R12. R12 this required is equal to, so total by opposite value. Okay. So this is now vice versa. Next in this case we are going to delta to, so delta values is given and we are going to calculate these new values. So that purpose we have the formulas. These are the formulas. Okay. Based on these formulas we are going to perform some problems. Let us do. Solve problems on star delta, delta star transformation. Here is given the one simple problem. What is the problem? Convert the given star network to equivalent delta network shown in the figure. This is the figure is given. Okay. Now is a numerical value is given. So 1, 2, 3 nodes. You can simply just, it is the one node, second node, third node is given, and here is the resistance values are also given. Okay. What is the resistance values here? Is instead of here 2 values is given, 4 values is given, 8 values is given. Then this values is converted into delta values. We are going to convert these values. So same 1, 2, 3. So this is R12, R23 or 31. So equivalent, by knowing this 2, 4, 8, what is the value? Simply write it the same value, so nothing will happen. So here same given value, write it. Okay, so what is the value? 2. What is the value? 4. What is the value? 8 is given. So based on this one, so just write the unknown values R12. I want this value now. So you know the equations. What are the equations? You know it, very familiar. So write it that equations. Okay. So what is the value? I want this value. Simply opposite value you are going to this one. Okay. R12 is required. Just this is a by, only simple word. So write it that directly. So what is the formula? Okay, you write the formula first case. Oh, sorry. What is that? Now same values we are going to do it. So the here is the values, star values are given only 2, 4, 8. So we will do this problem. Okay, here we will do. Okay, here what is given? Star values is given. Terminal. This is terminal 1, terminal 2, terminal 3 is given. Okay. Now I want to know that what is the resistance value given? 2 ohms, 4 ohms and 8 ohms is given. I want to convert the delta. So here I am going to write it equation in delta. So okay, I can write it. So now I am going to write it here equations. I want to know these values. This values I want. This R12, R23, R31. So what is the value? So here we are going to write it equations. Simply R12 is, I want to write it. So R12 is the sum of this value. What is the formula? We write it R1, R2. Okay. So sum of this all values. So you are going to write it R1, R2 plus R2, R3 plus R3, R1. Okay, divided by opposite. What is the opposite? Here this is we can set this is R3. We have seen. Now what is the R1? R1 is given is equal 2 ohms, R3 is given 4 ohms and R3 is given R3 is given 8 ohms. Okay, so based on this one you are going to substitute in this equation. Now so what is the value you are going to get? So simply substitute the equation. Now so R1 is the 2 into R2 4 plus 4 into 8 plus 8 into 2 divided by what is the R3? 8. So you are going to get 2 4s are 8 plus 4 8s are 32 plus 2 8 2s are 16. Then by you are going to 8 value. Okay. So such a way that simplify it. What is the value? Here you are going to get it 32 plus 40 plus 40 56 by 8. Seven, 8 ones are 8 sevens are 8. So answer is 7. Okay. So this value we are going to get R12 is converted to the 7 values. Okay. Simply substitute the value. So now you are going to calculate another value. So this value equal to That means you are going to get is equal to here equal to 7. Now I am going to calculate here also. So what is the value? Simply write it the same value. So same value is equal, we are going to the R23 is equal, numerical value is equal, same R1 R2 plus R2 R3 plus R3 R1 divided by here opposite is the R1. Simply write it. So numerator is the same 56 divided by what is this one? 2. 2 ones are 2 twos are 2 eights are 28. Okay. Now coming to the this position R31. So R31 I required. Numerator is the same. What is the value? 56. Divide. What is the opposite? This one 4. Okay, that's a 4. 4 ones are 4 ones are 4 fours are 14. So how it is simple? So once your basics, then numerator is the same. One numerator, denominator is going to change. Then we got it 7, 28 and here 14. We got it equivalent values. Okay. So very simple these problems. You can do these similar problems. Okay. What we are here going to this? So given data, what is given? 2 ohms is R1 is given, R2 is given and R3 is given these values. Now simply substitute these equations in the given equation. Okay. So what the value? This based on this one. So simply substitute the equation. We are going to the same value, got it 7 ohms and 28 ohms and 14 ohms. Simply substitute the our formulas. We got it this value. Okay. Now do the another. So whatever the you got it. So is given the old values. Now convert as the new values in delta. 2 values here consider this is a circuit is equivalent circuit. Now if I converted this to this, I will get the same values. Let us try it. Okay, we will do it. So now is given the what is the value? So we got it 7 and 28 and 14. Simple this one. So whether you are going to convert, yes, shall we do it? So now do it. Now here you can take it. Delta values is given now in this case. Okay, 1 terminal, so 2, 3 delta values is given. What is the values is given? This 7 ohms, here is 28 ohms, here is the 14 ohms. Okay. Now I want to convert values into equivalent values star. So I want star values as required. What is the R1? What is the R2? What is the R3? I want to know. Okay. So what is the value you are going to get? R1. What is formula? This is required. Adjacent values. So this into this. Okay. Adjacent values. What is the formula? So R1 is required. This R12 into R23 formula. You know that formula? So this is what is this one? Represented previously. R1 and 2 na R12, R23, R31. So what is the formula? R1 is required. R adjacent this value, R12 into R31. Okay. So divided by sum of these values. R12 plus R23 plus R31. Okay. So these values for this R1. So simply what is the R12? R12 is equal to, we got it 7 into R31. R31 is this one 14 divided by 7 plus 28 plus 14. So what is the value? So 7 plus 14, 20 and 48. We are going to the 7 into 14 by 48. Okay. Now simply simplify it. Okay. 7 into 14 by 4 into 8. 2 7s are 2 2s are 2 8s are 7 1s are 7 4s are. That's the value. Okay, just wait. Okay, here's something mistake. Where is the mistake? Okay, so you have to careful. 7 plus 28 plus 14 not okay. Okay, here is the mistake I done. Okay, here is the instead of this is the what is the value here? This value is the 49, not 48. Okay, so simply write it here. So while doing the calculations, dear students, don't confuse it. Okay, be careful. So here what is the value? So this is equal to 7 into 14 divided by 49 value. Okay, so what is the 7 28 14. Okay, so we are going to what is the value? Here is the what is that? 15 plus 4, 19. So 1 year. So 49. So I mistakenly written 48. That's why I am got complex. So if you do any mistake, you are going to face so many problems. So please careful while doing the problems. Okay. Now so 49. 7 ones are 7 sevens are 7 ones are 7 twos are 1 into 2 2 value. So previously we got it 2 value. So whether you're going, so what is the R1 value? 2 value. Previously we have seen 2 values got it. Okay. Similarly, you convert, do the remaining also. What is that one? R. So this value got it. What's the 2 value? Now R2 I want to know. Okay. Write it R2. R2 value I am going to write it. Okay, R2 is equal to, so this value I want to adjacent 7 into 28. So denominator is the same 49. Okay, 7 ones are 7 sevens are 7 ones are what is the value? 4 are. So that's the value of 4. This is a value similar to the previous one. Okay, same value got it. Okay, now so we write in the same value. This the value is equal to 4. Now similarly you convert another value. So another value is equal to this one, you write it. Now R3. So write it R3. So R3 is equal to what is the value? So denominator is the same 49, but whereas numerator R3 I want this known, this value is known. So this value into write it, this value I want to know, this value into this value, 28 into what is the value, that one, 28 into 14, write it the simple, that one, 28 into 14. So we are going to get, so our same value, that is equal to, so we are going to get the 8. Okay. Similarly, so now what we have seen, either here star is given, the star values converted from delta values in this case. Okay, whatever the delta values is given, we converted once again same values. In previous class, previous problem, whatever the star values is given, convert to the delta values, and delta values is given, we convert to the star values. So either cases the resistance values does not change. whether you connected network in star or delta, its ohmic values are similar. Okay, this is a one simple example how if star values is given, how the delta equivalent resistance converted, and delta values once again reversed connected in star, then equivalent resistance we got it same values. Okay, so here is it is proved that the resistance ohmic values are does not change whether you are connected star or delta. Okay, so you can do the similarly you do the remaining problems. Okay, so this is a one star to delta, delta to star we have seen. Okay, so this value is converted this value and this value is converted this value. Similar basic formulas. So we got it the same values. Now do the another problem. So here what is a convert the given delta to the equivalent star network. So here is given the delta values. So we are going to convert the values. What is the values is given here? 50 ohms, 30 ohms, 20 ohms is given. So we are going to convert the star values. Simply write it. So you write the star values. Then what is the this value required? R1 is equal to simply this into this, 50 into 20 divided by sum of the values. What is the value? 50 plus 30 plus 20. Okay, don't mistake here also. 50, 50, 100. So that is equal to, write it simply 50 into 20 divided by 100 values. Okay, 100. So what is the value? 50 ones are 52 are 2 ones are 2 tens are. So we got it 10 ohms equivalent. R1 is equal 10 ohms. Simple. Okay, now I want these values. Then what to do? Similar process, you apply it. Now you got it. So I require the R2, this values are named. So R2 is equal to numerator changes, denominator is the same 100 values. Okay, into I want this value, this into this. Okay, that is called 50 into what is the value here? 30. Okay, same 51s are 52s are 2 1s are 2 15s are. So you got it the 15 value, simple. Now I want another value. So this value I want R3 is required. The write it the R3. Simply R3 is equal to same 100 and so here 30 into 20. 30 into 20. Okay, divided by 0 0 this 0 0. Then what is the value? 3 2s are 6. This is a value. So simply we got it. All values are we got it. R1 is equal to what is the value? 10 ohms. R2 is equal to 15 ohms. R3 is equal to 6 ohms. Simple substitution, equivalent value were calculated. Okay. Now you see in the animation. So these are the values is given. R12, R23, R31 is given, and we are going to convert in the by using the formulas. R1 is equal to what is the formula? So R adjacent values is equal to R12 into R31 by R12 plus R23 plus R31. Simple substitute the values. So R1 is equal to 50 into 20 divided by 50 plus 20 plus 30. That is, we are going to get what is the value? So simply 10 ohms. Then R2 value. So numerator changes, denominator is the same. Then what is the R2? Adjacent of R2 is equal to what is the value? R23 into R12. So simply we are going to get the value 50 ohms. Now R3. So we are going to get numerator changes, denominator is the same, and you write the simple substitute the value. You are going to get the 6 ohms. These are the values in star equivalent network. Okay, so these are the simple problems we are going to do. So here what we have converted, so you can see here, so is given the these values. Now converted these values. What are the values is given? So these are converted from these values. Okay, delta equivalent, you can see here in delta equivalent 50 ohms, 30 ohms, 20 ohms, higher values. So where if we connected the same resistance values into the star values, the equivalent ohmic values reduced to 10 ohms, 15 ohms, 6 ohms. So there is a delta to star. So whether it is possible to convert this star to delta once again, whether we are going to get the same values, these values, yes, obviously we will get it. Okay, you do the homework, that is the convert whatever the this star is given, you convert to the this value, we are going to get this value. Okay, now and you do the remaining another problem. Here is one problem is given, somewhat complex. So what is given? A resistive network is shown in the figure. Determine the value of equivalent resistance at the terminals A, D using delta star transformation. You can use star or delta, delta or star as per your convenience. Each person has view and different way. So your aim is to simplify the circuit. Your aim is to find one required characteristics in a particular element. So you can do as simple as possible. Okay. So there is no fixed method. So you can assume whether you are going to delta to star, star to delta. Okay. Now, so you can let us analyze this. So what is given? Here is a simple, one network is given. Here just like Stone bridge network is given and connected one resistance here. So what has happened? Now it becomes a delta, two deltas. So it is not parallel, it is not series. So what to do? So whatever the delta you are going to here, you convert into star. Then what? So star value, what will happen? So automatically if you are connected, if connected here, then what will happen? So this will goes and this will goes. Simply now we are going to get it delta place, we are going to get it, and whether from C you are going to this value, you are going to this value, you are going to this value. Now what is the network? Simplified. This and this are the series, these are series. Okay. Now what will happen? These two networks are parallel. Now this simplify it. So you are going to this one and you are going to both are parallel and this is a one network. Now this and this is simple. Now you are going to make it this one. Now other you are going to get it. So this is the steps. Okay. Now we are going to the basic network, series parallel network. Once you are converted from delta to star, whether this one or this one as per your requirement, then you are going to get this network. Now what is happening? These are the series, these are the series. Simply make it this one. Now it becomes a parallel, then simplified it. Then both are series, simplified it. You got the answer. Okay. So what is asking? The value of the equivalent AD. Where is the A? This is a A, this is a D. That means this is a A, this is a D. We got it. Okay. So dear students, you have to practice it. So what is the circuit is given here? One circuit is given based on, so this is the one resistance, this is another resistance. Now we are going to simplify this one. Okay, 6, 3, 9, 3, 4.5. So we are going to, this is values given. Okay, once again I am going to simplify in that circuit. Just you do the, you practice it. Now, so you can see what is the values given. Write the same equation. Okay, now your resistance is given, and you're connected one resistance across this one. Okay, now you're connected another resistance, you're connected another resistance. Now you're going to this one, this is a A, this is a D. Okay, so it's given the terminals. So what is the value is 6 ohms, 3 ohms, 9 ohms and 3 ohms and 4.5 ohms is given. Okay, now so what to do, whatever the value is given. Okay, now this is for example the B, this is a C terminal. Now here A terminals resistance, B terminal, this terminals, now this is a A, this is a B, this is a C, this one. So is given the 6 ohms, this is given the 9 ohms, this is given the 3 ohms. Now I am going to convert, now convert in the star these values. Okay, I want this value R1, R2 and R3. Okay, now how we are going to convert the R1 is equal to adjacent value, this one. So I want this value, so this value into this value, 3 into 6 divided by total values. What is the total values? So 6 plus 9 plus 3. Okay, so what is the value you are going to get? So this is 15 plus 18. Okay, so 3 into 6 by 18. Okay, 6 ones are 6 3s are 3 ones are 3. So that value you are going to the 1. So R1 we got it the 1 ohm equal to 1 ohm. Similarly R2 is equal this value I want to know. Okay, R2 value is this value. So R2 value is equal to what is the 6 into 9 divided by same thing 18. 9 ones are 9 twos are 2 ones are 2 threes are. So we got it 3 ohms. Okay, now similarly R3 you are going to calculate. So another value that is equal to R3, this is the R3. So R3 value is equal to, we are going to, what is the value? This value into this value, 3 into 9 divided by 18. So 3 ones are 9 ones are 9 twos are, so 3 by 2, that is 1.5 ohms. Okay, now simply substitute these values. Now we are going to write it. Okay, so now this network is converted. Now similar. Now what will happen? So E written here, this one, remove this, remove this, remove this. Then what is the network you are going to get? This is the network. This one, this is a, this is a B, this is a C. Now here already we have this one previously. Okay, this is this one, this is a D. Now what is the value you got it previously? So we got it. So what is the value? 1 ohm and 3 ohms. This is a 1.5 ohm. Simply substitute these values. Here what is the value? Okay, 1 ohm. This is a 3 ohms. This is a 1.5 ohm. And previously we have this 3 ohms and 4.5 ohms. Okay, now you can see it here. What we observed is now 1.5 4.5, this and this in series, this and this is a series. I want the value in between this, stretch it, then I am going to get equation. So what the equation I am going to get? Now simply I can write it. So this equation similar, this is a terminal. Now so here what will happen? This is a one resistance. Here I am going to resistance this one. This is value. So what is the value here? So 1 ohm. Here 3 plus 3, 6 ohms. 1.5, so 5, 6 ohms. Okay, I am going to 6 ohms here. Simple. Now both are parallel and equivalent. So we are going to convert further. Okay, further we are going to convert further. What's the value? Okay. Now so here 1 ohm resistance and here 1 ohm resistance. 1 ohm, 6 into 6, that is the 3 ohms. Now A, this is a D. 6, 1 plus 3 in series circuit. Simply write the series. 1 plus 3, that is equal 4 ohms. So you know the 4 ohm. Then R A D is equal 4 ohms. This is the equivalent resistance across the AD. Okay, dear students, it is very simple. Without using star delta, you may get the very difficult to find the equivalent resistance. So by using the KCL KVL, once you are converted the network and simplified with the help of the star, you are going to get it. Now you can, after knowing the total resistance, and if you know the, if value is given, for example initially is given some value, what is a 12 volts is applied across the terminals, then what is the current in the circuit? I can easily calculate. So V by this one, so 12 by 4, 3 ohms is going to the current. From this current we can find that wherever we require the current, branch current. Okay, so similarly you can do the problem. So what we have seen, so this problem is given initially. Okay, so this problem is given. Okay, this problem is given initially. Okay, the problem, this whatever the delta is converted into star equivalent values and return these values in simplified this value. Then from this one, so simplified with series parallel circuits. So we are going to get this value. From this one we are going to this value. From this one we are going to get this value, and from this we are going to get the ultimate value. Okay, so these are the very simple problems. Now in animation, what he has done, you can see it. Same, whatever this one. So here the delta values is given. What are the this way is converted into star. Okay, so equivalent this value, this 6 9 ohms, 6 9 ohms is converted to the this value from this network. Now you calculated these values, we got it 1 3 1.5 from 6 9 3 ohms. Okay, from this one further simplified. Now what is happening? So we are going to get this all values. So applying the basic formula, we are going to get this values. Okay, now so this circuit, we got it all things. Now the original circuit, so what has happened? So here original circuit, whatever the this delta connected values, so now it is converted to the star. Okay, now then after that we are going to the simple series and parallel circuits. Now this is given and is connected to this one. So this is the same, and this both are the series, and here simple is circuit and two parallel circuits. Now applying the series parallel circuit, we are going to find that. So this resistance and this resistance, after this resistance, these are the well known for you. Okay, so we converted the state is this step 2 and this step. Now simple, from this 2 we are converted this one, and these are both are connected in 4 ohms. This is the 4 ohms. Okay, so these are the simple series parallel circuits. So dear friends, so it is very easy to calculate any network by using our basic theorems. In this we are applied KCL and KVL, not in an equation point of view, and we applied the series parallel circuits and delta conversion. Okay, so do the remaining problems. So what you have seen here, we how the star and delta formulas for star to delta, delta to star, and we performed few problems based on numerical values. Okay, so do the remaining all problems. If you are having any problems, please ask in next class.